Hi everyone, miss you all. We'll talk today about square roots. They have another name which is radicals. Square roots or radicals. So what's meant by square roots? The word square, we know it, something like this. And the roots or roots of plants. But our concept today is about something different. It's not a square, it is not a root of a plant, it is this symbol. This is the symbol of a square root or a radical. This symbol is not free. It should be linked or related directly to a number. I cannot say a square root without completing the word. Square root of what? For instance, square root of 4, square root of 2, square root of 3. What is meant by radical of 4 or square root of 4? What does it mean? I'm looking here for a number. When I multiply it by itself, not by another number, I will obtain 4. Something times the same something, I will obtain 4. It's wrong to say 1 times 4. I'm looking for a number by itself. We have nothing but 2 times 2 equal 4. So I will say that the radical of 4 is 2. Let me repeat it with another number. What is radical of 0? I'm looking for a number. When I multiply it by itself, I will obtain 0. 0 times 0 equals 0. So simply radical of 0 is 0. Now observe these equalities. 1 times 1, first one, 1 times 1 equal 1. So simply radical of 1 is 1. 2 times 2 equal 4. We have done it before, so radical 4 equal 2. By the same way, 3 squared equal 9, or 3 times 3 equal 9. So radical 9 is 3. Let's apply for other numbers. What is radical of 16? It is 4. Why? Because 4 squared equals 16, or 4 times 4 equals 16. 4 multiplied by itself. We can say also radical 4 squared equal 4. Similarly, radical 25 is 5. Or we can say radical 5 squared equal 5. Radical 36 is 6. You know why? Yes, because 6 times itself equal 36. Or 6 squared, radical 6 squared equals 6. So let's have other radicals. From the multiplication table, radical 49 is 7. Do you still remember that 7 squared equal 49, or 7 times 7 equal 49? Now radical 64 is 8. We know why, because 8 times 8 equals 64. So radical 64 equals 8. And radical 81 equal 9. You know why, because 9 squared equal 81, or 9 times 9 equal 81. Now we will reach this rule. Observe it. It says that radical n squared equal n. N should be positive. I will repeat, radical of n squared equal n. And n is a positive number. Some numbers, like 2, like some prime numbers or some composite numbers. 2, I'm looking for a number. When I multiply it by itself, I will obtain 2. Nothing. I can't have this number. I can't have this number from the multiplication table. It is found. We can find it, but only through calculator or through complicated multiplications. So radical 2 on the calculator, it gives you 1.4142135, etc. It is not simple number. It is a crazy number. We cannot forecast, for instance, the 20th digit after the point. We don't know it. We need to work it or check the calculator. We say that 2 is not a perfect square because its radical is irrational. Now observe this inequality. We have radical of -1. And listen for this music. It's talking about something dangerous. Radical of -1. So imagine number by itself to obtain -1. It's impossible. Why? Because minus times minus is plus, and plus times plus is plus. I can't have the same number multiplied by itself to obtain -1. So radical of -1 is impossible. It does not exist. Also, radicals of any negative number do not exist. So it is impossible to think about radical -25, square root of -4, radical of -100. All of these are impossible. They do not exist. So let's remember what we have learned today. We have learned that radical of n squared is n, and n should be positive. For instance, radical of 4 equal 2, because 4 is written as 2 squared. Radical of 9 is 3. And we have said that radical of negative integer or negative number, it is impossible. It does not exist. For instance, it is radical of -8 does not exist. Or radical -1. We have learned also that some numbers have indefinite or unlimited decimal but not repeating decimal part. These are called imperfect square. They are not perfect square. I cannot forecast the next digit after the point. I need to work it by hand or using calculator. That's all for today. See you tomorrow. Bye bye.